So today we will talk about usage of machine learning in online marketplaces. So a few words about me. So this is me, and I'm holding OLX logo in my head. So OLX is the company where I work. So this is online marketplace. We are present in many different countries, like in India, for example, in many countries in Europe. And I've been with OLX for 3 years almost. So most of what I'm going to share today with you is based on that experience. So the plan for today is first we'll talk about what marketplace is, and we will talk about different examples of online marketplaces. And then we will talk about different use cases of machine learning in online marketplaces. So this is a picture of a marketplace from my hometown in far east of Russia. So here you can see people who are selling some goods, so fruit in this case, so apples, bananas and whatnot. Actually, bananas, I don't think bananas grows in Russia, but they're still selling them. So I guess it's imported. And you also see people who want to buy some stuff, right? So people who came to that place to buy vegetables or fruits. Right, so this is a typical marketplace. You have these marketplaces in every city on earth, in every town, in every village. They are everywhere. And they are usually places where people meet to exchange goods and money, right? So a typical marketplace, you have a seller, right? Seller wants to sell some stuff, some goods, right? And then you have buyer. Buyer usually has money. So, and then they want to exchange money on the items. So they get the dollar to the seller, and the seller gives them the apple, right? So this is how marketplaces work. So this is a transaction, and this of course happens in a special place called marketplace. So if I'm a buyer, I have some money, I know where to go to exchange this money for stuff. And likewise, if I'm a seller, I have some stuff that I want to sell, I also know where to go to be able to sell that stuff. And that's why in all the cities, starting from, I don't know, thousands of years ago, we had marketplaces. Online marketplace is similar, except instead of like a physical marketplace, you have a website. And then instead of physical money, buyers have credit cards. But the idea is the same. So there are sellers who have things, there are buyers who have money, and then they want to make an exchange in a special place over a website, right? And these things are typically called two-sided marketplaces because we have the supply side, the sellers, so they have the stuff, right? And we have the demand side, the buyers, so they need the stuff from the supply side, from sellers. And yeah, so typically when we talk about marketplaces, we're talking about two-sided marketplaces because there are two distinct type of users. We need to think about each group. So we want to make sellers happy, we want to make buyers happy as well. And this is a website of OLX. So this is OLX Ukraine. So this is one of the websites of OLX that I personally work on. So here you see this is a typical online marketplace, online classifieds, where you have different things. So, so for example, here, if you can't read Ukrainian, so here, like somebody are selling air conditioning systems, and then so here are t-shirts, and here somebody is renting an office in a business center. So like all these things, so people want to sell these things, so they go to OLX and they publish a listing, and right, if people who are interested in buying a t-shirt, they also go to OLX, and they so we facilitate the transaction between sellers and buyers. I think in every country there is a website like that, like Craigslist, for example, or Gumtree or others. And yeah, but this is not the only example of a marketplace. So you can think of other places. So for example, Etsy is a place for artists to exchange, to sell their art. So let's say if you're a painter, you want to find a place where you can sell your paintings. So you go to Etsy, and in Etsy you can sell it, right? And there are people who are interested in art, so they go to this website. They know what kind of stuff they expect there. So this is typically handmade things or art and so on. And Yeah, so the Etsy helps these people find each other. Another example is Airbnb. So here, it's not a physical thing that you sell, but it's more like a stay, overnight stay at some, like if you're traveling somewhere, you need to crash somewhere. So you use Airbnb to fight short-term rent, right? So here the supply, the seller side is people with the flats, the apartments, and the demand side, the buyers, people who need a flat, right? Then Upwork is another example of a two-sided online marketplace. So here, let's say if you're a company and you need a freelancer to do something for you, then you go to Upwork or Fiverr or some other freelance websites and you find the freelancer. So in this case, the companies are buyers. So they need a freelancer, and freelancers, they are sellers. They sell their time, their services to the buyers. And Udemy is another example. So Udemy is a platform for courses. So for course creators, so they can go to Udemy to sell their courses. And there are learners who want to buy courses, and Udemy makes it possible to make the transaction on this website. And even things like Uber, so a ride-hailing service, this is also a good example of a two-sided marketplace, because you have on one side you have the sellers, the supply. These are the drivers who sell their time and services, right? And the demand side are people who need a ride. So this is also a great example of a two-sided marketplace. And you can think of like there are many different examples of such marketplaces. And now, by now you probably understand what a marketplace is. Let's go through usage of machine learning in online marketplaces. So the first thing that you can think about is a recommendation system. So let's say we have a marketplace, e-commerce store, for example. We have a main page and we want to display some things that could be interesting for the buyers. So we want to help buyers find what they are looking for. And for that, we know some interests of the buyers. And we know, okay, this buyer is interested in electronics. Let's show some electronics to this buyer. And of course, our goal is to show something that buyer wants to buy, right? So we want to make this transaction happen. Alternatively, if buyer clicks on something, on a listing, on some item, we want to show them related items. So for example, in case of e-commerce, if you want to buy the latest iPhone, you need to get a charger, to buy a charger separately, so you can also display that. Or in case of usual marketplaces, like maybe you can show other iPhones, right? That the buyers might explore before they make their mind like what exactly they want to buy. Usually the way it works, you can think from, you can start from simple things like counting things to neural networks. So let's say if we talk about these recommendations on a homepage, on the homepage, you can start with just counting the most popular things and displaying them. Okay, in this country, what are the most popular items? And chances are that maybe people who visit the page, they just like popular stuff as well. So this is a good baseline. And then you can improve this baseline by using collaborative filtering. So this is a special approach that helps us to come up with two vectors, like user vector and item vector. So with collaborative filterings, you have like you have user matrix, you have vector matrix, and you can basically put them in the same vector space. So let's say this is a user, these are the items. And if some vectors are close to the user vector, they are similar, right? And this is what we can use for making recommendations. And there is a very nice article about that called Matrix Factorization Techniques for Recommender Systems. So if you want to find out more about that, check this article. It's really great. And this is what we can use for recommenders, right? And for on-page recommendations, on item page recommendations, we can use again these collaborative filterings because we have the vectors that we get from doing this matrix factorization. And for each item, we can just find what are the closest, most similar items, and we can display them on the page. And instead of relying on matrix factorization techniques, we can just replace that part with a neural network. So to produce, so we get some information about the item, we put this in a neural network and we get a vector. And then we can use these vectors to, again, do the similarity search. And this is what actually we use at OLX, and this is what our colleagues from Avita also use. So this is, you don't need to understand what's going on here. The idea here is at the top, you get the item. So the item, and there are multiple features from the item. And then at the end, you combine these features to get one single vector. And then you use these vectors for making predictions. So these slides, I'll share the slides. If you're interested in finding out more about this, you can just follow these links. So we talked about recommendation. So in recommendation, our goal is to help buyers find what they're looking for, and search serves the same purpose. So when a buyer comes with a specific idea, specific thing they want to buy, so they go and they usually use this search box. So if they want to buy an iPhone, they come and write iPhone there. So we want to display something that is relevant for them. And for that, we use usually things like TF-IDF. So in TF-IDF, Apache Lucene is a tool that implements that. So with that, you can index any item you have on your platform. And then when somebody, and for that, for indexing, you put a title, description, all the characteristics of the items. So you put this to Apache Lucene, Elasticsearch, or Solr. And then when a user has a query, so you just send this query to our index, and it returns back, it gives back all the items that we that are relevant, right? And this is like to know what is more important, what is not. We use TF-IDF, which is a special approach for finding important terms. You can find out more about this in a great book by Christopher Manning and others. It's called Introduction to Information Retrieval. The idea here is we represent documents and queries in the same vector space again, and we use similarity between them to explain what is similar, right? What is relevant. And then I see that I don't have a lot of time, so I'll quickly skip that. I want to talk about one more example, which is trust and safety. So in trust and safety, we as a platform, we want to not have negative, like bad content on our platform. And imagine that somebody wants to sell a dog, right? So they create a listing, but they want to sell that dog so much that they create many different listings, and that create bad experience for the users, right? And for users, like for buyers, they don't like to scroll through many duplicates, right? So for them, it's bad user experience, right? So we want to remove duplicates from our platform. There are other issues. So for example, people sharing pictures with explicit nudity, with not safe for work content. Somebody is trying to sell a gun, so there could be fraud, there could be spam, so many different things. And online, as an online marketplace, we don't really want to have this on our platform. So we can have a system for detecting this kind of content. So it's called the content moderation system. So when somebody creates an item, it goes through an automatic moderation system. And then this system decides if this item should be accepted or rejected. So if item is accepted, it goes live on the platform. If it's rejected, it doesn't go live. In many cases, this system can make a decision. So we need humans, moderators who look at the listing and make the final decision. So the type either goes live or not. And of course, in these cases, we record the decisions of the moderators, and we can retrain our models to be better in the future. So, and usually this automatic moderation system contains many different components, like a component for duplicate detection and component for forbidden items detection. So for example, if somebody is trying to sell a truck, it's fine. If somebody is trying to sell a fridge, it's fine. But if somebody is trying to sell machete, it's not fine. And our system will find that and will let us know, hey, this shouldn't go live. Or the same with duplicates. And if you're actually interested to learn more about duplicates, so there are two pages, two articles on our blog where you can read more about this. And I don't know if I have more time now. Please tell me if I should stop and answer questions, or maybe just cover a bit more. Because I see that it's 17 minutes. Okay. Sorry.
We have a little bit of buffer, so no problem.
Okay, yeah. Okay, so another example is, so we talked mostly about improving the experience of buyers, right? So recommender systems, searches, how to help buyers find the content. Trust and safety is for safety again for buyers and like to have a good buyer experience. And seller experience is about helping sellers, right? So let's imagine that you want to sell a car, right? And what you do for that is you take your phone, you take a picture, you go to OLX or some other website. So you put title, description, and then you reach this field, price. And if you're a first-time seller, you have no idea what to put here. You don't want to put a price that is too high. You don't want to put a price that is too low. So you want to have a good price, right? So to help these sellers, what we can do is we can build a model that looks at different characteristics of a car, like model, make, description, age, mileage, all that. It goes in the model and the model outputs the price, right? And then using that, we can make user happy, right? So they don't need to do a lot of research to come up with a price. Or many sellers, they maybe don't think it's important to have images of good quality, but it actually is. And one way to help them highlight that some images do not have good quality is building a system that can look at a picture and say, okay, this image is good, but this image is bad. Consider replacing this image. And in addition to just looking at images, we can look at the entire listing and we can understand like if it's good or not and make actionable suggestions, right? And then let me quickly go through a last use case. So we talked about helping buyers, we talked about helping sellers. Let's talk about making more money for us as an online marketplace. So imagine a scenario that you want to hire a car. So you want to get a ride. So what you do is you open your ride-hailing app, you get a car and you go where you want, right? But what if you just, there was a show that just ended, and after this show, you want to get a car because you want to go home, and you're not alone. There are 100 people with you also trying to get an Uber, right? So in this case, this example is called a search. So there is a search in demand. All of a sudden, many people want to get a car. They want to hire an Uber, right? So we can, as an online marketplace, we can see that this is happening and we can increase the price. So people, maybe they are desperate to get home, right? So if we just increase this price 3 times, they still want to get home. And still there are many of them. So probably if half of them decide not to hire a car, the other half will. So we kind of will be able to meet the demand this way by increasing the price, and we will help the drivers make more money and we will make more money ourselves. And this doesn't just apply to ride-hailing services. So let's think of a like usual online marketplace where you want to, as a seller, you want your ad get featured. So like you pay some money to the online marketplace and then it gets like featured. It's showed in more cases. So like maybe it has some special border around it or something like this. And then like we can show this ad when people are looking for iPhones. For example, if somebody wants to sell an iPhone, or if somebody wants to sell a Huawei, we can also show a Huawei for these searches. But the number of people who are interested in iPhones is probably larger than the number of people who are looking for Huawei. So the demand is higher. So here we can think, okay, what price makes sense here to put for featuring this specific item, right? So if the item is more popular, so perhaps we can ask for more money, right? Okay, I think that's it. So you can all agree that ML in marketplaces helps everyone, helps buyers, helps sellers, and helps online marketplaces make more money. And if you have any questions for me, you can find me on LinkedIn. You can find me on Twitter. You can find me in DataTalks.Club, which is an awesome online community. There is Slack. And I hope I still have time to answer your questions.
Mm-hmm. Yeah, thanks, Alexey, for this very good and extensive overview of what's going on in the marketplace space. We have a few questions here. So first question is very good, coming from Andre, because he's wondering, there's like collaborative filtering on the one side for recommendation, like a battle-tested method, and on the other side, you have the brave new world of neural networks, which are like a more complex extension, basically, of this topic. And he's wondering, like, okay, are there situations where the one outperforms clearly the other one? And maybe question for me on top, is it possible to quantify that a bit? What's the added value of that kind of approach?
Yeah, of course. So these more traditional recommendation systems like matrix factorization, they suffer a lot from a problem called cold start, right? And this is where neural networks, they can really add to that. So that's one of the examples. But in general, with neural network, it's easier to incorporate all the information that you have about the listings. Like you have the title, you have the description, you have the, category, you have all these things that you can easier incorporate into your model with a neural network. It adds a lot of complexity on top of that, but usually you see the return. And a good way of measuring this is A/B test. So you basically, let's say you have your current system, which is a baseline, right? And then you have the new system, which is a neural network. And then on part of the traffic, sees the new system, right? And part of the traffic sees the old system. And then there is a metric that you care about, like, I don't know, number of transactions, for example, or things like this. And then you can just see, okay, for this group with a neural network, is the number of transactions actually higher than for this one, right? And this is how you can quantify. And sometimes it happens that for some approaches, baseline is actually not worse, right? And then you can ask yourself, does it make sense to add this extra complexity? And usually the answer is no, right? If they are not better, and then you just keep using the old approach. So that's this. I would say that's the standard way of testing if a new method works better than the old one.
And collaborative filtering you would consider as a baseline in this kind of world?
Yeah, I would even like as a baseline, I would consider a rule-based approach. Like some simple heuristics like counting and all that, because with collaborative filtering you have this cold start problem. And before neural nets were popular, usually there were some other search-based approaches or simple rule-based approaches. So I would also consider them as baselines.
Okay. Like one question, because OLX seems to be quite a diverse company, and you showed us one architecture. So did you manage basically to push that architecture to all your different sub-companies, or do you have different teams working on different recommenders?
So that architecture that you saw on the slide, it's actually not something we have at OLX. At OLX, we have something similar, but that was coming from one of the company from OLX Group. And by OLX here, I meant OLX Europe. This is the business unit where I work, like European OLX. And that was coming from our colleagues from Avito. So Avito is a company in Russia. So they actually came up with this approach. It's called item to vec. So basically you take an item and you vectorize it. So, and we pre-produced this approach, and it also worked on our data. And so there are some differences, because these are different websites, right? So the people are different there. I mean, the user base. But in general, we noticed that some approaches that work well in one companies of the OLX group, they also work well with others. So that's one of such examples. And if you are interested in how we at OLX Europe use this, so there is a video that I linked, I think, here somewhere. I think it's, here. So this one, the first one is an article in Russian. So if you know how to read Russian, you are happy because you can read the blog from Avito. But if your Russian is a bit rusty, then you can check this video from my colleagues, which is in English. Luckily, that explains a similar architecture that we use at OLX Europe.